Welcome to another session of Circuits and Networks. In today's class 5 under GATE exam problems on resistance equivalent networks, we're going to see uh, the problems which are involved with the resistance calculations, like finding out the resistance equivalent network, finding out the resistance for the given circuit, that is generally called as R equivalent, one of the star delta problems. So all these things we are going to see in this class 5. So basically, we'll start with first question. In figure, RA, RB, RC are 20 ohms, 10 ohms, and 10 ohms respectively. So RA, B, C of delta network are given as 20, 10, and 10 ohm respectively. The resistances R1, R2, R3 in ohms of an equivalent star connection are options given as 2.5, 5, 5. B option as 5, 2.5, 5. C option as 5, 5, 2.5, and D option as 2.5, 5, 2.5. So this question was asked in GATE 2004. This problem was asked for 2 marks. So let us see how we'll sort out this problem. So first, consider this delta network. You should know how to obtain a star network or star equivalent from a given delta equivalent circuit. For that, we have standard formula of R1 which is placed between RB and RC. So we can see you can connect a resistance by assuming a node at the center of this particular delta network. Then we will get the value of R1 as RB RC whole divided by RA plus RB plus RC. Similarly, the resistance R2 from the given delta network can be obtained as RA RC divided by RA plus RB plus RC. And finally, the value of R3 would be RA RB by RA plus RB plus RC. So this is how the formula is formulated from the given delta network. Now, if at all you substitute the given values, that is 20, 10, and 10 ohms respectively, I'll get the value of R1, which is nothing but RB and RC, that is 10 and 10. So it becomes 10 into 10 by 20 plus 10 plus 10. This value will be nothing but 100 by 40. This value is nothing but 2.5 ohms. Okay, so when you look into the options, either you should have an option A or option D, and B and C are not the options. So this is how you have to easily get the shortcut by looking into the first R1 value. Now let us go with the R2 calculation. R2 is placed between RA and RC. So the values are 20 into 10 by 20 plus 10 plus 10, that is 200 by 40. So this becomes 5 ohms. Now still we have a confusion from the given option whether it is A or D. So for that again we need to solve for R3, which is nothing but 20 into 10. Fortunately RA RB value are also equivalent to RA RC values. So therefore the value of R3 would be 5 ohms. So from the given options we are going to get A as the final answer. So this was asked for 2 marks. In the next problem, consider the star network shown below. The resistance between terminals A and B with C open is 6 ohms. Between B and C with A open is 11 ohms. And between C and A with B open is 9 ohms. Therefore, the values of RA, RB, RC are. So this was asked in GATE 2001. This is also for 2 marks. The solution is simple, but you need to concentrate on the given data. So look at the options. You have RA equal to 4 ohms, RB equal to 2 ohms, and RC is equal to 5 ohms. Where the rest of the options are same, RA, RB, RCs. So we need to find out what exactly is the value of RA, RB, and RC. Okay. So from the given data, RA plus RB with C as open, you got as 6 ohms. So take it as equation 1. Again, RB plus RC is equal to 11 ohms. With A as open, frame as equation 2. And last, RC plus RA is equal to 9 ohms with B open. So this frames an equation 3. Now we have equation 1, equation 2, equation 3. Now what we'll do, we'll subtract equation 1 from equation 2. So equation 2, it is having RB plus RC equal to 11, whereas equation 1 is Ra plus Rb equal to 6. So if at all you subtract first equation from second equation, we are going to get Rb plus Rc minus Ra minus Rb equal to 11 minus 6, which is equal to 5 ohms. Let me treat this equation as 4. Now add equation 4 with equation 3. What is equation 3? You have Rc plus uh, you have you have Rc plus Ra equal to 9, and we have this equation 4, that is Rc minus Ra equal to 5. So when I'm going to take the addition, this Ra will get cancelled out. I'll get 2Rc equal to 14. In fact, Rc would be equivalent to 7. Now when you look into the options, Rc value we got as 7 ohms in option B. So directly you can go with the option B as the right answer. Still, if at all you want to check the further solution, let us frame this Rc equal to 7 ohms as 5. Now what we'll do, we'll substitute this Rc, and we have this equation 3, that is Rc plus Ra equal to 9. Therefore Ra would be equivalent to 9 minus 7 would be equivalent to 2 ohms. So you can see clearly we got the option B. Still, from equation 1 you have Ra plus Rb equal to 6. Just now we got the value of Ra as 2, and Rb equal to 6 minus 2, which will equal to 4. So this is how the solution is framed, and that is how these type of questions we would ask for 2 marks. So B is the option. Now in the third question, it's a fill in the blank. The equivalent resistance between terminals A and B is dash ohms. So this was asked in GATE 2017 under set 1 for 1 mark. The problem seems to be complicated, but it is not so complicated. Let us see how. So for that, first you observe from the termination side, AB is on the left side, and on the right side you have 1 and 1 ohm. So these two are in series. So that's why I wrote here 1 plus 1 is equal to 2 ohms. So these two are in series, and that is connected in parallel with 6 ohms. So this 2 is in parallel with 6. So what is the value we are going to get? We are going to get 6 into 2 by 6 plus 2, which is nothing but 3 by 2 ohms or 1.5 ohms. So this 6 parallel with 2 can be replaced as 3 by 2 ohms from the above input, that is 3 by 2, which we have obtained from the given data. Now this seems to be a complicated network, whereas you can see 3 ohms is in parallel with 3 by 2 because you don't have any branch, so you can treat this as particular node, that is a ground node. In fact, 6 and 3 on this side are parallel. So what I'll do, I'll observe the calculations, that is 3 ohms is parallel to 3 by 2 ohms and 6 ohms is parallel to 3 ohms. Still you have a confusion, so what we'll do, we'll read out the circuit. Now you can see 3 and 6 are in parallel, 3 and 3 by 2 are in parallel, and in between these two, 2 ohms is plain. Now I think it is easy for anyone to solve this particular network. Now 3 and 6 are parallel, so 6 into 3 by 6 plus 3 or 3 plus 6 will give you the value as 2 ohms, whereas this parallel combination, that is 3 parallel to 3 by 2, will give you the value as 3 by 2 into 3 by 3 by 2 plus 3, which is equal to 1 ohm. Hence I'll reduce this network to this network, where I have replaced parallel combinations with 1 and 2 respectively. Now this is the reduced network of this network. Now this 2 and 1 are in series, and the combination is in parallel with 2 ohms. So again we'll take the parallel combination formula, that is 3 parallel to 2, that is 3 into 2 by 3 plus 2, which is nothing but 6 by 5 ohms. So now I'll replace this parallel combination with 6 by 5. So it becomes 1 by 2. Now 1 by 2 is in series with 0.8 and 1. So overall the R equivalent between A and B is obtained to be 2 ohms. I hope you got the solution. Nothing but you need to see the parallel and series combinations. Otherwise, you have to go for star delta approach. For example, instead of this ground node, if at all some resistance value has been given, for that particular resistance, you need to concentrate on star delta transformation, which would become a complication. That is why for ease, they have removed a resistance parameter between these ground terminals and they have connected a common ground, and that is how we got the solution of RAB as 2 ohms. Now, in question 4, you can see RA and RB are the input resistance of the circuit as shown below. Okay, the circuit extended infinitely in the direction shown. So which one of the statement is true? Whether R is equal to RB, or RA is equal to RB is equal to 0, or RA is less than RB, or RB is equal to RA plus 1 by RA. So how to solve this particular network? You can see RA starts from 2 ohms, a T network followed by 1 and 2, and that is followed till the infinity. Whereas RB, it starts from 1 and followed by a pi network, whereas 212 is again repeated of RA. So in fact, for the solution, I'll take RB first, that is 1 ohm, and I have the rest of the network, that is 2121, which is T fashion connected in infinitely. I'll connect this to as RA. Now it is easy for us to get the solution. So it was a typical question as in GATE 2016 for 1 mark. If at all you have patience, you can easily look into these two circuits or in networks and you can get a common relation. Now you have RA parallel to 1, which is the R equivalent of RB. So RB would be equivalent to RA, that is RA into 1 by 1 plus RA. So option D is the right answer. Now it's a very common question. You must have seen this question before. This was the basic question which was asked in GATE 1992 for 1 mark. So we have to find out the equivalent current for this given circuit. Uh, all the resistors in the circuit of the figure are of 1 ohm each. So every resistance is of 1 ohm each. We need to find out the value of current when the voltage is 1 volt. Okay. For this, what we are going to do, since all the resistance are of 1 ohm, so this is 1 ohm, this is 1 ohm. So likewise, you have parallel combinations. So for that, what I'll do, I'll take for these two parallels, that is 1 and 1, again 1 and 1, 1 and 1 and 1 and 1. So 1 and 1 will give you the value as 1.5. How 1.5? This is 0.5 because 1 and 1, 1 into 1 by 1 plus 1, that is 1 by 2 is equal to 0.5. That 0.5 added with 1 ohm. So likewise, we'll get the value as 1.5 ohms. So this top combination is replaced by 1.5. So this entire combination is replaced by 1.5. Now similarly, you have another combination, so 1.5. Again, you have another combination, that is 1.5 and 1.5. Now these combinations again are in series with 1 ohm, 1 ohm, and again the combination is series with 1 ohm. Now what I'll do, 1.5, 1.5 parallel is there, right? So 1.5 parallel with 1.5 give you the value as like this, as 0.75. So 0.75 added with 1 will become 1.75. So I have replaced this T network over here. There is 1, 1.5, 1.5 with 1.75. Similarly, on the bottom, I'll get 1.75 and a 1 ohm. This is kept as it is, 1 ohm. Now these two are in parallel. So the combination will give you the value as 0.875, that is 1.75 parallel with 1.75. In fact, 1.75 divided by 2 is nothing but 0.875, and you have 1 here. So now we have turned this complex circuit into simple circuit. Now with the help of Ohm's law, V equal to IR, I'll get the value of I, which is equal to V by R. V is nothing but 1 volt divided by R value is 1.875. So this value is nothing but 1 divided by 15 by 8, which is equal to 8 by 15 amperes. So this is how you solve the gate related problems pertaining to R equivalent circuits or networks. So D is the right option for the given problem. So in today's class, we have seen some basic problems which were asked as R equivalents, and these questions are framed approximately in GATE 1992, GATE 2016, GATE 2017. So I hope you like this particular class or session. Please share among your friends and subscribe to this channel, and please press the bell icon for the future notifications. Thank you.